Topic 2-2, multiplying monomials. This is actually in several sections of Chapter 7 in our whole textbook, Section 1, 3, and 7 on the pages listed here. Okay, let's look at, you might make several notes on your paper about what happens when you have a multiplication of two common exponents, common variables with exponents. You have to remember that you do not multiply these, you add them. That's like having 3x's and 5x's, so that it would be x to the 8 power. Likewise, x to the 7 times x to the 4, just a visual to see all of them written out. You count them up, it's 7 plus 4. So the pattern is that we add the exponent. So here's just showing the rule that's being used on this. When you multiply and the bases are the same, the bases here being the x's, that's considered the base. That's the exponent. I'll draw lines to it. The exponent is what's hanging up in the air like that. So use exponents or the pattern you discovered when you simplify. This one's different in that, well, you have coefficients in front. So the coefficient in front of a variable, when you have it in parentheses, is also understood to be multiplied, not added. There's another way of writing it. You don't always have to put a time sign, or in algebra we use a dot a lot. So if it's in parentheses, you know you're multiplying these two terms. Multiply the coefficients, but add the exponents. Be careful there. Multiplying the coefficients gives us a negative 15. Adding the exponents is going to give you 3 because it's understood to be a 1 when there's not one. If you do not have an exponent with your base, you do understand it to be a 1. That's why this is 3. And then B, 3 and 4 would be 7. Okay, this one's in steps. 2 times 1 is 2. 2 times a negative 3 is negative 6. You've got 1a, 2a's, and 2 more would be 4. Counting up your b, 1b, 2b, and 5 would be 7. Alright, then you get into problems that add or to it, and that is one like number 4, and that there's several things to do. Now, you can multiply across your coefficients, and make sure when you multiply, you keep it with your coefficient. And then this is a 2, that's a 3, so that's 5. A y1 and a y5 is a y6. But then you can't stop here if this reduces. You can use your calculator, put it in 240 divided by 15, and then math, enter will give you the reduced fraction. This one ends up being a reduced fraction. Actually, it'll end up being a whole number. This is just reducing it once, and then it becomes 16 x to the 5th y to the 6th. Okay, moving on. Let's look at number 5. Alright, lots to look at, but you got to be careful. These two are multiplied because the monomials are sitting in parentheses. But there is a plus sign here. So you're not going to start multiplying everything from here, here, to here, to here because of that plus sign. You have to stop, just multiply like we did on the previous page, and then add the two monomials together. And the reason we can add these together is they're like terms. A 6x, and x to the 6, and then a y to the 7 are considered a like term. So a positive 8 and a negative 6 will give you a positive 2. Alright, looking at this one, you are going to distribute. You are multiplying that negative 6 by the t squared, the 5t, and a negative 9. Distribute. You're multiplying completely across. Number 7, the same thing. The p squared, q squared has to be multiplied to each term inside the, oops, there's only one term there, inside the second parenthesis. There's just two terms. I'm getting a little crazy there, but you are going to be multiplying, so it's adding exponents. but this is understood to be a 1, and a 1 times a negative 2 is negative 2. Distribute the negative 3RS in number 8 to all 3 terms. So look closely and copy this answer, but notice how your RS was there, but in the second term there's also a T. There's no variables here, but there are here, so when you multiply a negative 3 and a negative 7, it becomes a positive 21, but it takes on the term on the outside with the negative 3. Okay, and then here's one that's a geometry question, and this is finding the perimeter and the area of the shaded region. We have to remember that perimeter is adding up all around the outside. Well, if we didn't know what this top one was, we do know because it's going to be the same as this right here, BC. You don't know this section, but you actually can just slide that value from here to here down as being 4BC. So mark that on your paper because you don't have these numbers here, here, and here. The reason this is 3BC is if this whole thing is 5 and you have 1 here and 1 here, that's 2 BCs, and then 5 minus the 2, that would be making up the difference. Right here would be a 3 BC. Slides over, so this becomes 3 BC. So for perimeter, it's just adding them all up. You're going to just add every one of those up. So you've got 20 BC once you start adding. Area, however, is length times width. Well, you actually have 2 areas. You've got the area of the first one, which is 3 BC times 4 BC, because this would be your, well, I'd probably call that the width times the length. So this would be your area of the first one, if you can see that. And this rectangle that I've separated right here would be your second one. So then you're just taking the multiplication of length times width. So this one would be BC and 5 BC. You're multiplying that times that because that's the width of that one rectangle and this is the length of that one rectangle. Then you're just going to add these two together because they do have the same variable combination. You do get to add the 5 and the 12 to make 17. And that concludes 2-2.